Let's see alcohols. So for alcohols, the names end with ol. Functional group is OH. So if you have one carbon, so that's methanol. So only one carbon attached to OH, and then you fill everywhere with hydrogen. So skeletal formula, if you still remember, the skeletal formula is where you have the lines. So you're not showing any carbon or hydrogen, you're just showing lines where each end, each dot represents a carbon atom. So here the skeletal formula is just going to be OH, like this. And then structural formula, CH3OH. 2 carbon atoms, so ethanol. So 2 carbon atoms and then the OH, and you fill everything with hydrogen. Now the skeletal formula, there's 2 carbon. So 1, 2, so just join these, and then the OH is bonded to one of them. So then you can have OH here. So this represents a carbon, this represents a carbon, and this carbon is bonded to an OH. So this is the skeletal formula. The structural formula, so you have CH3, CH2, OH. 3 carbon, propanol. So you have 3 carbons, and then the OH is bonded. And the skeletal formula, so you have 1, 2, 3 carbons, so join, and then you have 1 OH bonded to a carbon. So I'll put the OH like this. Okay, so then CH3, CH2, CH2, OH. You can also write CH3, CH2 twice OH, like that. 4 carbon, that will be butanol. So 1, 2, 3, 4, and then the OH. So 1, 2, 3, 4 carbon. So 1, 2, 3, 4 carbon, join, and then you have your OH. And then CH3, CH2, 3 times OH. 5 carbon, similarly, pentanol, and then you have 5 carbons. And then the skeletal formula, so 1, 2, 3, 4, 5 carbons, and then you have an OH. Okay, so then you have CH3, CH2 4 times OH, and from this you can see that the general formula is CnH2n plus 1 OH. Okay, so if you write the molecular formula for each, so you see that you end up with this general formula. Okay, so let's try to name these alcohols. So you have the skeletal formula given. You should be able to name any organic compound given the full structural formula, skeletal formula, structural formula, or molecular formula. You won't be able to name it, but based on full structural formula, skeletal formula, and structural formula, you should be able to name any organic compound. So 1, 2, 3 carbon, so that's going to be a propane. Okay, and then you have the OH, which is bonded to the second carbon. So this is propanol, and the OH is bonded to the second carbon, so 2-propanol. Or you can also write propan-2-ol. This is also acceptable. So propan-2-ol. Sometimes you'll see propan-2-ol, sometimes you'll see 2-propanol. It's the same thing. Okay, here you have 1, 2, 3, 4, but as you can see here, if I use this numbering, OH will get the number 3, so it's going to be too high. So I'll start numbering 1, 2, 3, 4 like this. So this is butane, so the butane chain, so butanol, so 2-butanol. here I have 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So either way I count, the OH will still be on carbon number 3. So this is pentanol, so 5 pentanol. Don't forget the hyphen. Now here you have the alcohol and you have the methyl side chain as well. So this is a CH3. So here you have 5 carbons. Don't forget that this is a carbon as well. So you can number like that, or you could number like this as well. So 1, 2, 3, 4, 5. But as you can see, the methyl here is getting a higher number. So we'll go for the first numbering. It's okay to try different possibilities when numbering, just to check that the functional groups that get the lowest numbers possible. So this is going to be a 2-methyl. So 2-methyl 3-pentanol. So the 3 is for the OH and the 2 is for the methyl. You could also have 2-methyl pentan 3-ol. That's also possible, but let's keep it like that. Now you could also have such diagrams, ball and stick diagrams, to name in your exams paper. So these ones, you will all usually have a key with that, which tells you this is carbon and this is hydrogen and this is oxygen. So normally you have a key, but generally you have to be able to name these as well. So let's count the carbon. So 1, 2, 3, 4, 5. You have a side chain here. So the OH is on the 3rd carbon. Either way we count, it's still going to be on the 3rd carbon. So this is a pentanol molecule. So 3-pentanol. And then you have a methyl, which is on the 4th carbon. Now, if you count like this, the methyl will end up with number 4. So if you count like that, so 1, 2, 3, 4, 5. So the methyl now ends up on carbon number 2. So 2-methyl 3-pentanol. The OH is still on carbon number 3. So this is the one that makes the difference. So 2-methyl 3-pentanol. Now, if there are 2 OH groups in the molecule, it's called a diol. So, for example, here you have OH and OH. So 2 OH molecule. So this is going to be called a diol. So this has 2 carbons. So ethane. Okay, so ethane, there is 1 OH on the 1st carbon and the 2nd OH on the 2nd carbon. So ethane 1,2 diol. So you name the main chain and then 1,2 diol. Now you also have primary, secondary and tertiary alcohol. So if you look at this molecule, you have the OH, it's bonded to this carbon, and this carbon is bonded to one more other carbon. So this is a primary alcohol. This is the OH, this is the carbon considered, this is bonded to 2 other carbon, this is a secondary alcohol. This is the OH, this is the carbon being considered, so 1, 2, 3. So this is a tertiary carbon. So this is a tertiary alcohol. So with this we end with alcohol's functional group.